Hello. Hello. Good evening, everyone. Am I audible and visible? Hello, 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 hello. Am I audible? Am I audible? Hello, how are you, Kaushik? How are you, Kaushik? Let us wait for few minutes more for other students to come. So the topic is Newton's laws of motion. This is our topic. I'm waiting for few minutes more. Then all students will connect. Then I will start full-fledged. From 8:30 we will start full-fledged. Stay connected. The topic is Newton's laws of motion. It's a very important topic. Basically, Newton gave three laws. Let's wait for 5 to 10 minutes more, then I will start. Okay, let's start. Uh, First of all, we will understand the requirement of Newton's laws of motion. I hope I am audible to everyone. Please reply. Good evening, Sanjeev. I am fine, beta. Uh, am I audible to everyone? I hope my voice is absolutely clear. Uh, Good evening, beta. Shweta. Good evening. Please, everybody reply. Am I audible to everyone? Am I audible to everyone? Yes or no? Yes, you are. Yes, yes. Okay. So this is a very interesting topic. This is a very interesting topic as far as physics is concerned. The whole physics runs on this topic, that is Newton's laws of mechanics. Newton's laws of motion. Basically, it is one of the most important chapter of mechanics. Okay, it is one of the most important chapter of mechanics. Now understand why it is so much important, because mechanics basically deals with motion and cause of motion. So till kinematics, till motion in 1D or motion in plane, or you may know it with the name motion in a straight line, okay, and projectile motion and everything, circular motion. Till here, we only used to know the pattern of motion, how the motion is taking place, motion, how motion is taking place, how. Okay, now we will know the cause behind the motion, cause, reason we will know. Okay, so this is one of the most important part of mechanics, and this is the fundamental of mechanics, whether you are in class 9, whether you are in class 9, whether you are in class 10th, whether you are in class 11th, whether you are in class 12th. Okay, if you are 9th and 10th student aspiring for JEE and NEET in future, or if you are aspiring for Olympiads, science Olympiads, various science Olympiads, right? Then also the today's class is very useful. And if you are 11th, 12th student, and if you are aspiring for JEE or NEET or whatever, then also it is very important, right? So please listen very carefully, and I will give you excellent tricks that you will be able to do this question. Like it will be very easy for you for sure, right? Within seconds you will be able to do those questions, right? So first of all, we should understand what is the Newton's laws of motion. So in classical physics, that is mechanics, Newton gave three laws. First law, Newton's first law, that is, and the second one is Newton second law, and the third one is Newton third law. These are laws given by Newton which govern the which govern or control which govern or which govern or control cause of motion, or motion rather I should say, right? So we will understand in detail that what are these laws and how we should apply this. Okay. Okay, let us move forward. First of all, we will cover what is first law. So according to Newton's first law, if the net force if the net force on a body is zero, if the net force on a body is zero, then acceleration must be zero. It is a must. It is a must, right? So if net force on a body is zero, then acceleration must be zero. What do you mean by if acceleration is zero? It means that the change in velocity vector is a zero. Change in velocity vector is a zero, right? Change in velocity vector is a zero. Change in velocity vector is a zero. Now, what is change in velocity vector? First of all, you should understand that velocity is a vector quantity since it consists of both magnitude as well as direction, right? And if the magnitude changes or direction changes or both changes, in all these three cases, I mentioned three cases, right? First case, yes, yes, yes. Am I? My voice is clear now, Sanjeev? Yes, yes, yes. My voice is clear now, Sanjeev? Okay. So what I am saying, I'm going to repeat it again. Velocity is a vector quantity. Velocity is a vector quantity. What is a vector quantity? Which consists of both magnitude as well as direction. Which consists of both magnitude as well as direction. Now understand carefully. Okay, okay, it's okay, okay. It's okay, I'm repeating. Velocity is a vector quantity which consists both magnitude and direction, and even if the magnitude changes, even if direction only changes or both changes, in all these three cases, velocity vector changes, right? If the change in velocity vector is zero, it means the velocity is constant. Velocity is constant, right? If the change in velocity vector is zero, it means velocity is constant. Because if change in anything, change in anything, let it be x is 0, or I should say delta x is 0. Delta is a letter which represent change. Yes or no? Wherever you see this triangle, it means delta. Delta means change. So if delta x is 0, it means xf minus xi is 0. Xf is final value of x, xi is initial value of x, and if xf minus xi is 0, it means change in x is 0, because the final value and the initial value are same. You can directly write xf equal to xi, right? These are some code words of physics, right? These are some, you can say, slangs of physics in your Gen Z language. Okay, so what I'm saying, delta v is equal to 0. If change in velocity vector is 0, it means velocity is constant. And velocity is constant, it means what? It means that the magnitude is also constant. Understand carefully. Magnitude is also constant. Direction is also constant. Direction is also constant. Magnitude is constant, direction is constant. Yes or no? Remember always, nothing can change magnitude or direction. If even one of the magnitude or direction would have been changed, the velocity vector would have been changed, right? So this is a must condition. You should remember always. You should remember always that this is the must condition for. This is a must condition for Newton's first law. This is a must condition for Newton's first law, that if net force is 0, if the net force is 0, then acceleration must be 0. Or vice versa is also true, that if the acceleration is 0, it means the net force. What is net force? Net force is sum of all the forces. Sum of all the forces is net force, right? Sum of all forces. Sum I am showing by sigma. You must be knowing that sigma means sum, right? So sum of all the forces is 0, then it is represented like this: net force is 0. Then if acceleration is 0, it implies the vice versa is also true, that if the acceleration is 0, then net force will be 0. And it means that there is either no force acting on the body, and even if the forces are acting, then the sum of all the forces, the vector sum of all the forces, will become 0. Am I clear? Am I clear to everyone till here? Till here, is there any problem? Am I clear to everyone? Till here, is there any problem? Till here, is everything clear or not? Please reply. Okay. So, one thing you should understand: few teachers do mistakes here. They often confused first law with law of inertia given by Galileo. It is not true. Of course, this class is a little bit numerical oriented. So, because the orientation of the class will be more numerical than theoretical, so I can't go into detail. But one thing you should understand, that these two things are not same. Okay, many books and many teachers will teach you that the first law and law of inertia given by Galileo is same, right? But they are wrong, right? And even if you will argue with them, they will start bothering you. But someday, when we will take theoretical classes in detail, I will explain you that first law is not equal to law of inertia given by Galileo. Okay, these two things are completely different, right? But some teachers teach it like that in that style, that these two have give the same lesson. No, they two talks about two different things, right? So these two are not same. Always remember. But today's class is more numerical, more numerically oriented. So we won't invest much time on these things. We just understand the basic concept and then we will attack the numericals. Second law. What is second law? Second law, according to the Newton, is sum of all the forces acting on a body. Since force is also a vector quantity, so it might be possible that at a time many forces are acting on a body. And if I add all of them, obviously I will add them vectorially. I can't add them like a scalar. In addition of a scalar, we don't have to put our brain. Just 2 plus 3 gives us 5. It's very easy. From 2 class till here, 9th, 10th, 11th, 12th, We have learned only this addition. Okay, 5 plus 6, it will become 11. We don't need to put our brain. Okay, so these are scalar addition. They does not follow any particular certain law, right? But the vector addition follows certain laws. Always remember, right? I can't haphazardly add that 2 plus 2 is 4. 2 plus 2 may be 2 root 2 also. So no, 2 plus 2 may be 0 also. 2 plus 2 may be 1 also. Yes or no? So there may be anything, right? So don't do rote learning that like scalar, they cannot be added. They are added in different fashions. We will deal with those things also, right? Don't worry. So what I'm telling you, the sum of all the forces is zero. It means, sorry, the sum of all the forces is given by, we are discussing Newton's second law, no? Okay. So sum of all the forces is given by rate of change of momentum of the body. Rate of change of momentum of the body. Obviously, this is the net force. This is the net instantaneous force. And if we are talking about average, then it will become delta P by delta T. Both has same meaning. Okay, both has same meaning. Nothing difference. The only difference is one force we are in one case we are seeing the change in momentum in a large interval of time. Then we call it delta P by delta T. When we take time as large interval, right? But when we take dp by dt, it means we are observing the change in momentum in a small interval. That's why the change in momentum is also very small. So it gives us instantaneous force and it gives us average force. That's it. That is the only difference. The meaning is same, the force remains the same, the definition remains the same. The only thing in whole physics you can generalize it, that if the change in moment change in something by time is there, if the time interval is large, then it will give you average, and if the time interval is small, then it gives you instantaneous. That's it. So it is net force. Why I am mentioning net, why I am giving priority to this subscript again and again, that is the reason behind this is that a body can experience one force at a time, or it can experience multiple force at a time. You know that vectors are always represented by arrows. Vectors are always represented by arrows, and since force is a vector quantity, that's why I am representing it by arrows. F1, F2, F3, F4, all the forces are represented by different arrows, right? Why does we prefer to represent a vector with an arrow? The simple reason is vector has a magnitude and direction, and arrows have length as well as direction. The length represent the magnitude and the direction represent the direction part, right? The arrowhead represent the direction. That's why we represent vector by an arrow. Now understand very carefully, dp by dt is the net force, right? So what it will give you basically, now what is p? If somebody asks me what is p, p is momentum, right? So what is momentum? Some people, if someone will ask you that what is momentum, then generally what people says, generally I have seen this thing, what generally people say that momentum is mass into velocity. I'm sorry, but this is not momentum. This is definition, or rather I should say that this is formula of momentum. This is formula of momentum, mass into velocity. This is not momentum. This is formula of momentum. So what is momentum? It is total quantity of motion contained in a body. Motion contained in a body. Okay. If anybody asks you definition, then you tell this one, right? It sounds more smarter. Don't say m into v. So when I will differentiate it, it will become how much? It will become m dv by dt. This is how the differentiation takes place. Plus v dm by dt. Generally mass is constant. Okay. Whenever we multiply product of two functions now, this is rule of differentiation, that we do differentiation one at a time and leave the other one, right? And then put a plus sign in between them. Suppose I am differentiating v, then I will leave the m and I will write m dv by dt, and then I will put a plus sign in between them, and then I will write v dm by dt. Now it's a chance of m, not v. I will give one chance to both of them, m and v both. first of all, I will leave m and differentiate v with respect to t, and the second time I will leave v, I will miss v, and then differentiate m with respect to time. This is how differentiation takes place. It is necessary because we have many students who are lagging in basic maths also, especially NEET students. That's why these these things need to be addressed, right? So it is m dv by dt plus v dm by dt. Generally, in 99% of cases, mass is constant. And if mass is constant, for example, if you take a wooden block, if you take, then its mass is going to be constant. It is not going to change anyway, right? So it is obvious that the mass will remain constant. That's why dm by dt represents rate of change of mass with respect to time. And with time, since mass is not changing, it is constant. So I can say that dm by dt is zero. If something is not changing, then its rate of change with respect to time is zero. And zero into anything becomes zero. So it becomes m dv by dt. M dv by dt. Then tell me what is dv by dt? dv by dt is acceleration. So the force become, net force become ma. But always remember, this is not always true. Now I have seen many teachers teaching that net force is equal to mass into acceleration. Directly they teach like this. It might be possible that in your school or institute also, they have, in the name of Newton's second law, they have taught you this thing, right? But it is not always true. Okay, this is not Newton's second law. This is wrong. This is not Newton's second law. Okay, this is Newton's second law, that the net force is rate of change of momentum. Otherwise, what you will do in fluid mechanics, what you will do in the case of rocket propulsion, right? There the velocity in some cases will seem to be constant, but is still, in the case of rocket propulsion, since the mass is continuously changing, because the gas is ejected out, the fuel inside the rocket is burning and it is ejected out in the form of gas. So the mass is continuously changing, and that is yielding to the reproduction of velocity. It is yielding in the production of force, right? So basically, always remember that. Please remember the laws in its real form. Okay, people learn it in their artificial forms or derived forms. You should not. This is Newton's second law. I am going to highlight it. This is the Newton's second law. Okay, if anybody is teaching you other than this, it means there's something wrong with the guy. Okay, now listen carefully. Now if in some case you will see this also, that the velocity is not changing. I'm not kidding, I'm serious. The velocity is not changing, then dv by dt will become zero, since the acceleration is zero. If this part becomes zero, then what will happen? 0 into m will become zero, and this will become v dm by dt. V dm by dt it will become, right? So in this case, the net force, the definition of net force is different. It is some constant velocity into rate of change of mass. Rate of change of mass. Okay. So always remember that don't do rote learning. Okay. Always try to understand this concept. Till here, everybody is comfortable. Should I proceed forward? Till here, everybody is comfortable. Should I proceed forward? Please reply. Please reply, guys. Then I will move to the third law, and then after we will move to the numerical part. That is the most important. That is the most important part. Please tell me. Do you want, if you want to take the notes, you can take the screenshots. You can take the screenshot. Okay. Now I'm moving to the third law. Now I'm moving to the third law. Now I'm moving to the third law. It's very easy. It is always said that for every action, there is equal and opposite reaction. Now here, it is very a famous law, right? Even if in movies and in some sort of dialogue delivery or in stand-up comedies, we use this line, right? In daily life, we also use this line, okay? And you won't believe that this this law is itself inspired from Bhagavad Gita. Okay. So basically, what does it says? For every action, equal and opposite reaction. Here, action and reaction are in sense of forces, right? What is action? First of all, understand what is action and what is reaction. So here, since we are talking about Newton's laws, so in the context of Newton's laws, action and reactions are not stimuli and response, right? It is not something that is like stimuli from an external environment, and reaction is the response to the external event, whichever happening, right? Here it is only, here it should be taken only in the context of forces. So here action is also nothing but force, and reaction is also nothing but force. So I am rewriting this law. I hope that you would not have heard in this form that the real forces in this universe always acts in pair. No force in this universe acts individually. No force in this universe acts individually. Real forces always acts in pair. Okay. Now there are some unreal forces also, which we will study in the name of pseudo forces, right? We must not discuss that at this point of time. We must neglect it. Okay. But you should understand also always that the real forces, sorry, real forces real forces always occurs or acts, rather I should say that it acts in pair. So what is action? If there is a block and you apply some force and I call it action, for example, let us make like this. Suppose here there is a person who is applying force. Okay, applying force, and this is a mass of 10 kg, and the person is applying force of 10 newton on the block. So if the person is applying action, then the block is also applying a reaction force of 10 newton on the person. That is what law says. Now generally students got confused that if the action and reaction are equal and opposite, then they must cancel each other. So here the misconception is because the forces are not acting on a single body. Suppose this is a body of mass m, and if from right side there is a force of 10 newton acting from right to left, and if from left side there is a force of 10 newton acting from left to right, and since the both forces are equal in magnitude and opposite in direction, that's why they will cancel each other, because they are acting on same body. But here the 10 newton and 10 newton are not acting on same body, they are acting on different bodies, and that's why they have different effects. They have effects on different bodies. Because this 10 newton is acting on this 10 kg mass, it will accelerate it, and this 10 newton is acting on this body, so it will it may push this person in the backward direction, right? So always remember, here it is very important to understand that these action and reaction forces never cancel each other, because they are not acting in the they are not acting on the same body, but they are acting on the different body. If action and reaction are acting on the same body, then we won't call it action and reaction basically. Okay, in context of Newton's third law, if the forces are acting on a single body, and if they are in equal in magnitude and opposite in direction, then only they will cancel each other. Like in this case you can clearly see that this 10 newton is acting from left to right, and this 10 newton is acting from right to left. So here this 10 newton and this 10 newton both are acting on the same body m. Yes or no? So here the both forces are acting on same body, and they are equal in magnitude and opposite in direction. That's why they will cancel each other. But here this 10 newton is acting on this 10 kg mass, right? This 10 newton is acting on this 10 kg mass, and this 10 newton is acting on this person. So these two forces, although they are equal in magnitude, opposite in direction, but they are acting on different bodies. That's why they won't cancel each other. I think I'm clear to everyone. This is very important point of Newton's third law. Am I clear to everyone? Am I clear to everyone? Basically, what I mean to say in short and simple is real forces always acts in pair. They never acts individually. Whenever you will apply some force on any entity on this universe, maybe contact force, maybe non-contact force. Non-contact force means all those forces which acts from a distance, and contact force are those forces which acts on touching them, right? So it doesn't matter. Whenever there is some real force, they always acts in pair, and and there is one action and there is one reaction, right? And action and reaction, since they are acting on two different body, they won't cancel each other. One more important thing about them is they must be of same nature. So if they are if one of the forces is electromagnetic, then both must be electromagnetic, right? If one of them is gravitation, then both must be gravitation. It is not possible that action is a gravitational force and reaction is nuclear force. It doesn't works like that, right? So this is one more important point, that they must be of same nature. Third important point is both acts simultaneously. Generally, after studying the statement of this law, we have a misconception that action acts first and reaction acts later. It is a wrong concept. Okay, it is a wrong concept. Action and reaction comes together and vanish together. It is not like that, that action comes first, reaction come later on, or reaction comes first, action comes later on. It's not like that. It's absolutely a wrong concept. Both action and reaction comes together and goes together, right? They act on the body, they start acting on the body from same point of time, right? They don't follow each other. Okay, so that is the point. And you can call any one of them as action and any one of them as reaction. You can call action and reaction as action as reaction, and you can call reaction as action. You can swap the name also. You can swap the name also, because they are equal in magnitude, opposite in direction, just, and they are acting on the same point of time. Okay, so I think I am clear. All the three laws are clear. Shall we proceed to the numerical part? Shall we proceed to the numerical part? If you all are comfortable, shall we proceed to the numerical part? Please reply, everyone. Shall we proceed to the numerical part? Shall we proceed to the numerical part? Please, everybody reply. Am I audible? Okay. Everybody, please, I want interaction from everyone. It's my humble request that everyone should interact. Okay. Okay. Now let us see here. This is a very simple example. There is a block of m mass. There is a block of m mass, and this block is unaccelerated. It was mentioned that the acceleration of the block is 0. Now, what do you mean by acceleration of the block is 0? Now, generally, what students have a misconception is that if the acceleration is 0, it means that the change in velocity is 0. It means the body is at rest. But they don't understand a broader perspective. The broader perspective says that if the acceleration is 0, if the acceleration is 0, it means either the body is at rest, or it is moving with constant velocity. Either the body is at rest or it is moving with fixed velocity. Now, what do you mean by fixed velocity? Fixed velocity means neither the direction of the motion is changing nor the magnitude of velocity, that is the speed, is changing, right? So velocity magnitude is not changing nor its direction is changing. So it might be moving in a fixed direction with a speed of 2 meter per second. Okay, it might be possible that the body is moving with 2 meter per second in a fixed direction. It is also possible. It is not very big deal, right? So always remember this point, that they might show, for confusion, they might show that a body is moving with 2 meter per second, a fixed velocity they will give, and then you will start thinking that 20 Newton must be greater than 15 plus F. Oh my God, you are doing a very big mistake. Why? Because since the body is moving with fixed velocity, it means that the force on either direction must be balanced, because the velocity is not changing, nor its direction is changing, nor magnitude. Neither its direction is changing, nor magnitude is changing. It means force on the either side must be balanced, right? So you must understand that acceleration is equal to zero doesn't mean the body is at rest only. It might move with a constant velocity also, right? So this is 20 Newton, this is 15 Newton. So what is the value of F? F is 5 Newton, right? You must have seen question like this, in especially NEET. Now here you see, somebody asked me tension. Well, now what is tension? First of all, understand, whenever a string or a thread, okay, or a rope, but since here the rope is very thin, so it becomes thread or string. The purpose behind taking thin rope or threads or string is that the mass of these threads are negligible. Okay, in future we may take the masses also, we may consider the mass of the ropes also, but currently we are assuming that the threads are massless, threads or string. Whenever I write string or thread, automatically you should understand that it is massless. Basically, massless means the mass is there, but the mass is negligible. Okay, so we neglect its mass as compared to this block, right? When it is compared to the block. Suppose the mass of the thread is 10 grams and the block is 10 kg. So 10 kg means 10,000 grams. So what is the what is the value of 10 gram in front of 10,000 grams? There is no significance, right? So yes, Sanjeev, you are in which class, beta? You are in which class? Okay. So what I was discussing was thread is massless. Now, whenever we pull a thread, whenever we pull a thread, the intermolecular forces between the molecules of the thread make it tight. And when, as soon as the thread becomes tight, a force gets generated into it, and that force is called tension. Sanjeev, you are a very intelligent guy, yeah. So if you will study like this now, you will 100%. I promise you that I will make you qualify JEE and NEET, whatever you choose. If you have interest in that field, otherwise there's no use to take them forcefully. But if you are interested in either of them, I promise you, you will score AIR under 100 under a proper guidance. In my guidance, you may score all India rank within all India rank 10 also. That's my promise, beta. So stay in touch with me always. Okay? Because I have taught many students. This year also, JEE Advanced 238 rank is taught by me. Okay? I can't take the name, but there are many students whom I have guided and they have cleared IIT and NEET exams. Every year they qualify, especially NEET and JEE. We have many results. So please stay in touch with me, right? Okay, understood, beta? So let's come to the subject. So whenever we pull a string, we cannot push a string. If we will push a string, it will become, it will slack. Slack means it will lose. So if it will lose, there won't be any forces inside the thread, right? But if I pull that string, then whenever we pull that string, the intermolecular forces don't allow the strings to break down, and that's why the string become tight and a force gets created inside it. A force gets generated inside the string, and the force always acts along the string. Never do like this, that if the thread is like this, you are showing tension like this. It never takes place. The tension is always along the string, right? This tension is always along the string. Always remember, the tension is always along the string, right? So what I'm saying, that the tension is always a pulling force. Tension, due to tightness of the string, it comes, and tension is always a pulling force. Always remember, pulling force means it always acts away, in away from the body, away from the surface, whatever acts away from body. Note it down. This is very important point. These are the basic points where generally students do mistakes. Am I audible to everyone? Till here, I am clear to everyone. Please reply. Is it clear to everyone? Please reply, my dear students. If you won't reply, then how would I understand? Okay. So you must understand this is a thread. Thank you, Dilip. Thank you so much. This is a thread. Understand very carefully. This is a thread. This is a thread. Uh, there are many classes we are going to plan, okay, very soon, where there are many classes which we are going to plan dedicatedly for JEE and NEET. Numerical classes, numerical oriented classes we are going to plan for JEE and NEET, especially in physics, chemistry and maths, right? Some classes of bio we may also plan, right? So please, please, it's a humble request from my side that please subscribe this channel and please recommend to your friends also, because it will be a small token of gratitude for us. So please, it's a humble request that please subscribe our channel and please recommend it to friends also. Okay. So now listen here, focus here carefully. Focus here carefully. If it is a string, if I'm saying it, if I'm calling it as a string, it means I am considering it massless. Massless. Obviously, sir, it's a thin string. That's why we can neglect its mass. It's pretty obvious. No issues, right? Now you tell me, where should tension act? So if I talk about this surface, if I talk about ceiling, if I talk about ceiling, then the tension must act in the downward direction. This thread must be trying to pull this ceiling in the downward direction, because I've already said that tension always acts away from the body. Highlight it that tension always acts away from the body. And here the tension must act in the upward direction. Okay. Now the tension is acting in the upward. Always remember, beta, tension cannot be a pushing force. Tension cannot be a pushing force. It cannot push anything. For example, if you take a thread and take a wall here and you try to push this wall with the help of, if you try to push this wall with the help of this thread, then it is not possible at all. It is not possible, because the thread will become loose. The thread will become loose. The thread will slack. The slate will slack, and therefore you won't be able to apply force on this wall. But if you pull this thread, then you will be able to pull this wall also, right? Okay. So I hope you are understanding my point. Is this clear to everyone that thread cannot apply a pushing force? It always apply a pulling force. Okay. Is it clear to everyone? Is it clear to everyone? Please reply. Please reply. It's my humble request, beta. Please reply. Okay. Okay, let's proceed. Let's proceed. Now, focus here. If this 10 kg is experiencing a force in the downward direction, that is 100 Newton. How do you know, sir? Because the force experienced by a body due to gravitational pull is mg. Now, m is 10 kg, and g is acceleration due to gravity. Approximately, we take its value 10 meter per second square. So 10 into 10, it becomes 100 Newton, right? So this is 100 Newton and this is T, and T is equal to how much? 100 Newton. Why? Because if this body is unaccelerated, why? Because the body is at rest. If the body is at rest and remains at rest, the most important point is it remains at rest. If the body was initially at rest and it remains in rest, it means that the change in velocity is zero. If the change in velocity is zero, it means the acceleration is zero. And if the acceleration is zero, that means that the net force must be zero. And if two forces are acting and the net is zero, it means if the downward force is 100 Newton, then the upward force must also be 100 Newton, so that these two forces, equal and opposite in direction, will cancel each other, rather I should say will balance each other, and therefore it will result to a net force 0 on the body, and that's why the body will remain at rest. The body will remain at rest. Am I understood to everyone? Am I understood to everyone? Please, everybody reply. Am I understood to everyone? Am I understood to everyone? Okay. Now let us take this question. Now let us take this question. These questions are overrated question. I don't understand why teachers glorify them so much. These are the easiest question of physics. But you will see that people are glorifying like these are very good questions, this, that. I don't understand. If you will study physics from me, I guarantee you the physics will be the easiest subject of your life. If 10 kg is experiencing 100 Newton in the downward direction, it means the tension is also 100 Newton, because this body is at rest and it remains at rest. It means the velocity is not changing. It means the acceleration is 0, and it is only possible according to Newton's first law. It is only possible when the net force on the body acting is 0. If the net force acting on the body is 0, it means the acceleration is 0. It means the velocity won't change. So tension is 100 Newton. Here also the tension is 100 Newton. Here also the tension is 100 Newton. Now you must be thinking that these two are same thread and this is a pulley. Do you understand what is a pulley? Have you seen it? Have you seen it in, you must have seen it in gym. There are many machines, weightlifting devices where you have seen the pulley. Or the simplest example, if you belong to the rural areas, well, from where water we take, there is a pulley like system. Suppose this is a well and this is a bucket, and this is a rope, and there is a pulley system, and some individual pull this thing, okay, from ground. Have you seen pulley? Have you seen pulley, everyone? Okay. So in gym, in well, you must have seen pulleys. Okay. Now, if somebody asks you define pulley, then what you will tell? Can anyone define pulley? Anyone from your class define pulley? Any senior student? So pulley is a mechanical device which manipulates the direction of force without changing its magnitude. Okay, you can write it down if you want to write it. You can write it that it's a mechanical device which changes the direction of force without changing the magnitude of force. This device is called pulley. So here you can see I'm talking about ideal pulleys, right? Ideal pulleys are frictionless and massless. Okay. Now understand, here also you can see there is a single thread which is passing over pulley. Here the thread is passing over pulley. You can see here it is passing like this, right? So if you will see carefully, then you can see that this thread is going over the pulley and then it is going in the downward direction. Yes or no? And now it is connected to the 10 kg mass. Carefully you see that this 10 kg mass is connected to a thread. This thread goes over the pulley and after that it is connected to the wall, right? Now listen carefully. If this block is at rest, it means the forces must be balanced, and it is only possible that the gravitational force, that is 100 Newton, gravitational pull, must be balanced by the tension. This tension is balancing this 100 Newton, and that's why this 10 kg is at rest. Similarly, if here there is 100 Newton, here it is also 100 Newton. Same thread, same tension. Always remember, same thread, same tension. When I am talking about massless threads, you can write it here that if I am talking about massless thread or light threads, massless threads, same thread means same tension, because thread don't have their own mass, so it would not contribute in the total weight, right? Since thread itself has no mass, therefore it won't contribute into the force. So same thread means same tension. So here it is also 100 Newton, here it is also 100 Newton. Now you just understand, if I talk about this pulley, if I talk from this pulley's perspective, understand my point very carefully, that if I talk from this pulley's perspective, then you can easily feel, you can easily feel, then you can easily feel that this pulley is experiencing 100 Newton in this direction due to this part of the thread, and 100 Newton in this direction due to this part of the thread, because tension always acts away from the body. That's why I've shown like this. It will always act away from the pulley. In our village, we still have one or two wells where water is drawed. Okay, okay, it's a very good connection, Sanjeev, that you have related it with real life example. Very good. Okay. Now let us come to the point. Okay, someday if you become an IITian or a doctor, I will come to your village and then you show me those well. Okay, let's move forward. So we can see that this pulley is experiencing two forces, 100 Newton, 100 Newton. Okay, now how to add these forces? Since it is not a scalar quantity, so we cannot write 100 plus 100 directly 200 Newton. No, we cannot write. There's certain rules of adding a vector. So just listen carefully and notice here. I hope that you all guys know vectors. Okay, so if it is 100 Newton and if it is 100 Newton, these are two vectors, then the resultant is given by vector which will pass in between them, and the magnitude will be 100 root 2. And since the both vectors are equal in magnitude, so the resultant will pass in between them, bisecting the angle. If the angle is 90 degree, then it will be 45 degree and 45 degree. So it will something like this. So I can say that these two threads are applying a force of 100 root 2 Newton on this pulley. Now, if the threads are applying 100 root 2 force on this pulley, then this pulley must have moved into this direction, but it is not moving. Why it is not moving? Because pulley is itself connected with this hinge. This hinge it is connected. So if somebody asks you how much force this hinge is applying, so if somebody asks you that how much force this is hinge is applying, then it must be applying 100 root 2 Newton only, na? So this hinge must be applying how much force? This hinge must be applying 100 root 2 Newton force. 100 root 2 Newton force this hinge must be applying. Otherwise, it won't have been able to stop the pulley, and pulley would have broke from the hinge and moved in that direction. Am I understood to everyone? Am I understood to everyone till here? Am I understood to everyone till here? Am I understood to everyone till here? Please reply. Please reply. Am I understood till here? Everybody, please reply. Is it understood? Is it understood? Just a second. Just a second. My note app is not responding. Just a second. So I must be clear till here, I hope, right? Shall we move in, proceed in forward? Shall we move forward? Okay. Now listen here carefully. Listen carefully. Now let us take this example. Now let us take this example. Now I will tell you here a good trick. Here we will cover a good trick. Okay. Now listen carefully. Suppose that we are talking about this 10 kg, then this 10 kg is experiencing 100 Newton in the downward direction for sure. Now you are applying some force. Due to this force, this mass has been moved a little bit in the rightward direction so that the string or the thread connecting this mass to this point is making 45 degree with the vertical. Otherwise, this string must be vertical and this block must be hanging like this, right? But the things have changed. Why? Because if you are applying force in this direction, it will bend and it will bend at some angle, right? So what I'm saying is, if the angle is 45 degree as mentioned here, then they are asking what force you must have been applying. This is a simple case. Now understand very carefully. If it is T tension, then what generally people tell you to do is to break the forces into components, right? So here we need the concept of parallel lines, right? Understand carefully. I'm sorry. Okay. Now we here apply the concept of parallel lines. Since this line and this line is parallel, this blue line and this white line is parallel, then we can write that by the interior angle property, this angle is also 45 degree. Alternate interior angles are equal in case of parallel lines, and this is a transverse. Okay. Now I'm breaking these two forces. Do you know how to break the force? Suppose this is a force and it is making some angle theta with some direction, with some line. Then the force which is along this line is F cos theta. Only multiply cos theta and you will get the component of force which is along the line. And this will be F sine theta. Always remember that F must be in between cos and sine. You must not write like this. This is F sine theta. No, because here the F is not lying between F cos and F sine. It means you are doing something wrong, right? So obviously these are very basic things, but I have to tell because of my experience. I have seen many variety of students. So this is F. So if it is making some theta angle with the line, then it is F cos theta. The component which is along the line, along the that side which where you are seeing the angle, in the side of angle if you are seeing, then it is cos, and if perpendicular to that you are seeing, then it is sine. So I can simply write that component of tensions like this. I can break this tension into two components. I can break this tension into two components. One is T cos 45 because I am breaking along the theta, and this component will be T sine 45. This is long cut method, but still I am saying because you should connect the things. Now, obviously, if the body is at rest, if the body is at rest and it is hanging here, then obviously net force in X should be 0 and net force in Y should also be 0, because in if either of X axis or y-axis, if the net force won't be zero, the body will start accelerating in that particular axis, right? So the forces must be zero in both along both the axis, right? Now understand carefully. This T cos 45, this T cos 45 must be balancing this 100 Newton. So I can write T cos 45, cos 45 is 1 by root 2. It becomes T by root 2 is equal to 100 Newton. And this T sine 45 must be balancing F. So T sine 45 is again T by root 2 is equal to F. So here you will get T as 100 root 2. And if you put this 100 root 2 here, then it will become 100 root 2 by root 2. Directly you can see that LHS is same, then RHS must also be same. Rightly you can do that, but still then F is 100 Newton, right? This is the answer. Never try to do these questions in this method, like this method, okay? With this method, you should not do this question. Now I'm giving you a simple yet very effective trick. I'm giving you a simple yet very effective trick. Just understand carefully. I'm giving you a very simple yet very effective trick. I'm giving you a very simple but yet very effective trick. Listen very carefully. First of all, let me erase all these things. No need to do this much hard work. You just tell me that if this body is at rest, if this body is at rest at this point of time, it means this F force, this 100 force and this T force must be acting in such a manner, their magnitude and their direction must adjust in such a manner that the net force must be zero. Now you can clearly see that F and 100 will have a resultant passing in between them. Suppose, understand very carefully, suppose this F and 100 has a resultant. This F and 100 has a resultant. Okay. This F and 100 has a resultant R. So it is basically sum of vectors F and 100 Newton vector. Yes or no? This is sum of vector F and 100. And this R must be cancelling T. So understand what I'm saying. If A plus B plus C is 0, it means A plus B must be equal to minus C. Then only it is possible. Otherwise, it won't be possible. So if F 100 and T is 0, then F plus 100 must be balancing T. And must be, how it would balance? It would balance only if the resultant is negative of tension. Now negative in vectors show opposite in direction and equal to shows equal in magnitude. So in short, I should say that the resultant is equal in magnitude to that of T, but opposite in direction to that of T. I hope I am understood to everyone at this point. I hope I am understood to everyone at this point. Yes or no? Yes or no? Am I understood? Am I understood? Now the only thing which you have to do is if R and T are just opposite to each other, it means they are lying on the same line. And if they are equal in magnitude and they are just opposite, means they are lying on the same line. So if this is 45 degree and then this will be also 45 degree because they are lying on the same line. Understand very carefully what I'm trying to say. T and N, since T and N, wait, I'm changing the color. Uh, since T and R, that is tension and resultant, are just acting opposite to each other, it means they are lying on the same line. They are collinear. It simply means that this angle and this angle will be same. Yes or no? Okay. Now listen very carefully. Now you already know that we can displace a vector parallel to itself. I'm displacing this vector, and I can clearly see that 100, sorry, I can clearly see that the 100 Newton and this F Newton is making resultant R, which is nothing but equal to T in magnitude, I'm saying. And this angle is 45 degree. Now I can clearly see a right angle triangle. From now onwards, I won't do that much hard work. Okay, directly we will learn how to write the answers without doing much calculation. But because this is very first time, that's why I need to explain this thing, right? Otherwise, you won't be able to understand. So directly we can write like tan 45. This is a right angle triangle I can see, right? This is a right angle triangle. So tan 45 is perpendicular by base. So it is f by 100. Even if you don't have very trivial knowledge of vector now, even then you can do this question. And in the further class of NLM, I promise you, you will be able to do questions orally. That's my promise to you. And the tricks which are going to come in future are much more relevant, easy, and will make complicated questions very easy. That's my promise. So tan 45 becomes 1 by root 2, and it is equal to f upon 100. So f will become how much? 100 by root 2, it will become 50. Sorry, just a second. I've done a mistake. Sorry, I'm sorry. Tan 45 will be 1 now. Tan 45 will be 1. Sorry. Tan 45 will be 1. So F is equal to 100 into 1, that is 100 Newton. Directly you have written this answer. Am I understood to everyone? Am I understood? Okay. So let us do one more question. In order to increase your confidence, I'm doing one more question. I'm doing this question. This question I'm doing. This question. And I hope you do it orally. It's very simple. This is 10 kg mass. 100 Newton is acting in the downward direction. I hope it is understood to everyone. This is normal force. This is normal force. And this is tension. Sorry. This is tension, something like this. I've reduced the size of a sphere for clarity. That's it. In future, we will call this point as center of mass. Where we have concentrated the mass of the system. This is spherical system. We will call it. We will give a specific name to this point. That is center of mass. But for now onwards, right now, just you understand that I have reduced the size of this system for the sake of convenience. That's it. Okay. Now understand. If this is T tension, now tell me if tension is making 37 degree from here, because here you can see the tension is making 37 degrees. So I'm drawing some few lines. I'm drawing some few lines. Just cooperate with me. Okay. Listen very carefully. We can see clearly that these angles are how much? These angles are 37 degree and 37 degree, right? So obviously the resultant of normal and 100, that will be somewhere, that will be somewhere between normal and 100, because I am not sure that n and 100 are same or not, but still it will be somewhere between n and 100, must be balancing this t. Then only n plus 100 plus t is cancelling to become 0. Again the same concept, a plus b plus c is 0. It means a plus b must have been cancelling c. The resultant of a plus b must have been cancelling c. That's why the sum of a plus b is cancelling c, right? So, so this tension and this resultant must be lying along the same line, must be lying along the same line, because they are cancelling each other. We can clearly see, right? Okay, we can see that these are collinear, these two lines are collinear, these two vectors are collinear. Then I can say that if this is 37 degree by vertically opposite angle, this is also 37 degree, right? This is 37, then this is also 37. Now I am again shifting this n to the here, because we can parallelly displace a vector. If we are not changing the magnitude and direction of vector, then we can parallelly displace a vector. It is allowed, right? So I'm just I need some space. I'm solving here. Okay, don't get confused. I'm solving it here. Okay, so this is 100. This is n. Again, it is a right angle triangle, and this is r. And the magnitude of r is nothing but t. So r is equal to t. Magnitude wise, I am saying direction is just opposite. And so this angle is 37 degree. This angle is 37 degree. Now I can simply write that tan 37 is equal to n upon 100. That is perpendicular by base. The side which is in front of angle is perpendicular, and the side on which the angle is residing is base, right? So n upon 100. So from here we can write tan 37 is 3 by 5. So it becomes, just a second, 3 by 5 is equal to n by 100. It means it becomes how much? It becomes 60 Newton. N is equal to 60 Newton it will become, right? I hope it is clear to everyone. Tan 37 is perpendicular by base. Perpendicular is n, base is 100, and tan 37 is 3 by 5, and that's how I can write it as 60 Newton. Now tell me, what is T? T is resultant of n and 100. So it will be basically 100 square plus, by Pythagoras theorem you can also write, n is already we know na 60 Newton by Pythagoras theorem, and it is also it can be also derived by vector addition. 100 square plus 60 square is t square. From here t we can also find. So it makes your problem very easy. Have you understood the trick? Have you understood the way how to solve these questions? Yes or no? Everybody have got the point? Please reply, everyone. Thank you, Sanjeev. Thank you so much. So in future classes, we will see some. The today's trick is 2% is what I'm going in future, right? So stay tuned. Please subscribe the channel so that the future lecture must not be must not be missed. The lectures, upcoming lectures, must not be missed in any case, because you will be shocked to see that many NEET and JEE Main and Advanced question you will solve orally. You will be shocked to see that how physics could be so easy. Today's trick is just 2% of what I am going to deliver in the upcoming classes, right? So it is just 2%. And believe me, brother and sister, that in future classes, after attending future classes, I promise you that physics will be the easiest subject. I know that there is a misconception, or there is a huge misunderstanding that physics is the toughest subject, right? But I promise you, physics will become easiest subject, and then after you can attempt any PYQ, any book, and you will do questions like this in seconds. You will be able to do, right? So we will discuss later in upcoming lectures about these questions, right? And after some time we will do all those pulleys questions also. Many pulleys are connected, and police problems are generally FBDs we need to draw, and it's very difficult for the students. But I promise you, you will be shocked to see how I'm solving these questions, and you will solve this question within 5 seconds, I promise you. Okay, so stay tuned. If you have not subscribed the channel, please subscribe, recommend it to your friends. And that's all for today. Thank you so much. In upcoming lecture, we will discuss Newton's laws of motion in more detail, right? More numericals, tougher numericals, but of course the solution will be easier. Okay, thank you so much, thank you so much. Stay tuned. Thank you so much, my dear Arjunas.